Okay, so we already talked about the first law. The first law is basically just a law for conservation of energy. Now we are connecting internal energy with heat, with work. It's just energy. However, the first law does not tell us about processes that, even though they conserve energy, they never happen. For example, we never see heat or we never see energy going from cold to hot. We only see heat energy going from hot to cold. Now, there is another example here. We never see, for example, if we have a recipient, well, one side we have, let's say, salt, and on the other side we have pepper. If we shake this recipient, we know that we are going to get a mixture of salt and pepper all around. And it doesn't matter how many times we shake it, we'll never go back to this situation, even though there is nothing in the conservation of energy that tells us that this is not allowed. Another example, and there are several examples now about this direction. It looks like there is a preferential direction for processes to happen. Suppose we have here the ground and we are holding a ball up here, well, with potential energy. We know that this potential energy, as this ball falls, will become kinetic energy. Once this ball hits this floor, the floor will get a little warmer and this energy will just dissipate through the floor. We'll never see the opposite happening, on this energy getting together, accumulating on the ball, bringing it up by itself, and then hanging there in the air. Now, so there is always this preferential direction. Now, there is a lack of reversibility. We go in this direction, we never go back in the other direction. So this is what we call the second law. Now, so we had to add this second law of thermodynamics to try at least to justify or state it that there are processes that do not happen in nature. So the way that it was first discussed was back then during the Industrial Revolution, trying to develop heat engines. So the first way that the second law, how it was formulated, was with this sentence that heat can flow spontaneously from a hot object to a cold object. It will not flow spontaneously from a cold object to a hot object. Now, so that's how it was first stated, the second law. But this is very specific to the heat engines. It's very specific to this particular study. But as we said, the salt and the pepper, they will not separate. We don't have a ball going up by itself. Now, so to make this more general, a more modern way to talk about the second law is using the concept of entropy. And if we pick the system and its environment, the whole thing together, the entropy can only increase. So this arrow, this preferential arrow of all the processes is explained through entropy, which is going to show up later in this chapter. Very well, but let's continue with this discussion. What we want to do is, as we said in the beginning of the chapter, get our heat engines. So what is the idea behind a heat engine? Well, the idea is we have here some hot part of my system. We know, and here is cold, so we know that the heat is going to be transferred from the hot to the cold. We want to somehow, during this process, extract part of this energy to get work done, to get mechanical work. So that's the idea of the heat engine. So what is the idea? We start with this heat, now this energy that is leaving the hot reservoir, the hot part of our system. And instead of transferring the whole thing, what we are going to do is we are going to use part of it to get work done, and then the rest will be then sent to this cold part of the system. And so through this process, through this transfer of heat, this we are going to try to get some work done. So this is the equation that you're seeing here. An example. An example is the steam engine. It's an excellent example. What is the idea of the steam engine? And you see that this is very much connected with that problem. Let me just show to you again. This problem 15.7 that we talked about, where we had water, liquid water, becoming a gas. So what is the idea of the the steam engine? We have here a boiler with liquid water, and then we are going to boil it. How? With coal, with wood, or we're going to burn oil. Now we have some form of energy. So the idea is we are going to boil the water, and as it changes phase from water to gas to steam, the volume, as we talked in that problem, becomes extremely large, much bigger. Remember, we went from 1 liter of liquid water to 1671 liters of steam. Now, so it's an enormous change in volume. And what this steam is going to do, a lot of pressure will be exerted against this piston, so much that it will move the piston, and this piston is connected to a wheel, and then the wheel is going to rotate. So then we get our train, for example, our train moving. So the piston goes very fast to the right, no, or if you think about a train, it would be the piston going down to where the wheel is, and then when the piston comes back, brings this air through this pipe, because here we have a valve, it's going to open, it gets to this condenser, so that steam will now become liquid again, and then we have a pump to restart the process. So we have here a cycle. And so a steam engine, a heat engine, follows a cycle. Okay, well, so this is one example. Now we could use this enormous pressure, this huge volume that we created to move this piston. We could also use, for example, to turn this turbine. And so in any of these cases, what we are doing, transforming heat, part of this heat, into work. So that's the idea of the heat engines.